Hi, I'm Travis Connor, and this is my Physics 2212 Lab 1 about charged tapes. This lab involved creating charged pieces of tape and observing their interactions with each other. The purpose of this was to determine approximately how much excess charge is on one piece of charged clear tape. There are a few fundamental principles used in this lab. The first was the assumption that each piece of tape had an equal distributed charge. The second was that the pieces of tape could be modeled as point charges. In this experiment, I also used Newton's second law and Coulomb's law. I also used the approximate dimensions of an atom. The main results of the lab were as follows. Repulsion occurred when the two pieces of tape were 1.9 centimeters apart. I identified that the tape pieces were both positively charged and that the charge on each piece was 9.09 times 10 to the negative 9 coulombs. Also, each piece of tape was deficient by about 5.67 times 10 to the 10th electrons. Further assumptions I made were that air resistance was negligible and that the tape could be treated as a point charge. Additionally, I assumed each piece of tape had the same amount of charge evenly distributed. I modeled each piece of tape as a point charge to observe electric force interactions on a macro scale. Now moving on to the experiment. The system in this experiment were tapes A and B, and the surroundings were everything else in the lab room. My initial conditions were two pieces of neutral tape of approximately the same length and two pieces of tape attached to the table. The process for this experiment was then to tear off each piece of tape from the bottom piece at the same time. Then I held one piece of tape in the air stationary, while my partner brought the other piece of tape gradually towards the other piece of tape until the two started repelling each other. We then marked down the distance at which the two started repelling each other. During this experiment, I observed that the two U tapes repelled from one another. The tape was attracted to neutral objects such as my hand, and the U tape was attracted to a negatively charged pen. I concluded from this experiment that both U tapes were positively charged, and they exerted a force against one another, and that each tape lost electrons in the charging process. My data can be seen on the left. I used this data to calculate the force of gravity and then used this to determine the electric force. This was possible because the acceleration on the tape was zero. After evaluating the expression, I was able to find that the charge on the tape was 9.09 times 10 to the negative 9 coulombs. The number of electrons lost was found to be 5.67 times 10 to the 10th power, and the number of atoms on the tape was 2.482 times 10 to the 17th. For my coding, it can be broken down into three parts: constants, calculations, and objects. The constants included data about the tape and the charge of an electron. Under calculations, the force due to gravity was calculated, and then this value was used to determine the electric charge on the tape. The deficiency of electrons and atom ratio was also calculated using the formulas on lines 19, 21, and 22. The objects section was used to help visualize these interactions. On the left of the screen, the results section can be seen. In my model, there were some discrepancies, which were that the pieces of tape were not true point charges, and also that the charges on each tape were likely not equal. Also, the computational model serves as a perfect model, meaning it does not completely represent the tape experiment in the real world. My possible sources of error were differences in size of tape used, loss of charge on the pieces of tape during the experiment, and possible incorrect measurement of the distance between the tape pieces during the experiment. To answer the what if question, there would be no change because like charges would still repel and opposite charges would still attract. And to answer the why question, it is to keep the charged tape pieces from losing their delicate charge, and the tape may gain or lose electrons when coming into contact with other objects. To conclude, everyday objects can be used to model electric forces and identify electric charge. Newton's laws apply to electric charges, and careful analysis can allow us to determine electric forces, which allows us to model them accurately.